Okay, so we're still working on 7.1 of Savitch C++ edition 10. And this is the second part of 7.1. In this one, we're going to be talking about the variables and how things are happening in the memory. You don't have to really memorize that, but in a way to understand what's going on. And of course, with the memory and everything, we'll spend some time in computer architecture, assembly language to know what's happening in the memory. But we're going to keep just touch on it to see what's going on. So one of the things that we want to do, so remember, the size of the array has to be defined before we run the program. That can cause some issues. So I have 50 students, and in the future may go 60, 70, 80. So sometimes we are thinking that, okay, what about if we read the size from the user, and then we're going to build our array? A lot of new compilers are letting you do that, but that's not acceptable for all the compilers. And when we're writing the program, we want to be sure it's going to be compiled and run in different machines. Remember, for C++, for it to work, you have to compile it on that specific platform. So if you have a 32-bit machine, you go to 64-bit machine, you have to compile it again. That's something that Java tried to take care of. So reading a number from the user and use that number to create an array is not done through most of the compilers. So we are not going to do that. We are not going to do that one. So what we're going to do, we are going to go through this. We're going to have a data type. We're going to have the name of the array, hopefully a meaningful name, and we're going to have a declared size. So type name can be any type, int, double, string, character, and declared size is got to be integer only. And the suggestion is to create a global constant and use that one, but it has to be integer. You cannot use any other data type for your declared size. So when we create an array, the index that we can use is from 0 to declared size -1. So in this case, my size is 5. I'm going to start with 0, go to 5 minus 1, which is 4. So if I have size 5, I must not go to index 5. That is not part of my array. So how does this work in the computer? Basically, what happens is in the memory, everything is in bytes. So if you already taken this assembly language or something similar to that, or you have read it somewhere, 1 byte is 8 bits. So computers only understand 0 and 1. That's all they understand. So is it wise to put everything in zeros and ones? It's going to make it very, very hard for human to follow that. So at the beginning, they group them together and they put 8 of them as 1 byte. So everything in the memory is 1 byte together. Now, when we declare our variables, that variable is going to have a size. So chapter 2 went over the different sizes. Of course, some of these things may change depending to your computer. So I remember when I was working in industry, we were directed not to use int at all because the int would change its size from different computers. So if I had 16-bit machine, my int would be 16-bit, which is 2 byte. If I would go to 32, then it's going to be 4 byte. So it would change. And that would be a problem. So moving on is whenever we create a variable, and that's why C++ and languages like that, Java and similar to those, they are creating the variables ahead of time. That means they're going to go in the memory and they're going to reserve that much space in the memory. So when they are running, they don't have to worry about it. It's already there. While scripting languages like what we were doing last chapter for drawing graphs and those kind of things is doing that at the runtime. So a scripting language, no matter what it is, always slower than compiled languages. So we're going to declare an array. So remember, if I declare a variable, it's going to go to, so let me write it, do this, let me do drawing over here. So when I have a memory, inside the memory, I'm going to have a section for my program. And in my program is divided in 3 sections, but I'm going to talk about only 2 parts. One for my code right here, one for my data right here. So whenever we declare variables, they're going to come here and they're going to be right after each other. So they are going to be created in the memory, and the memory location of this data part is relative to starting of my program. And that's going to be the way it's going to be calculated. So if this time my program is going to start at address 1 million, this is going to be 1 million plus something. And if next time it's start at 2 million, it's going to be 2 million and something. That's called relative. I'm not going to get to it very detailed because you have other classes that you learn it. And remember, these are just for your information only, so you don't have to worry about it too much. So when we creating an array, let's say that I don't have nothing in my program, and the first thing I do is A6. So it's going to come here, and it's going to start from here, and it's going to reserve a space over here for array. So how does do that? It's going to say, okay, it's type int. So it's going to figure out what's the size of int for this machine. And it's going to multiply it by 6. So if it was a 16-bit machine, that's the example that your book is using, that's 2 bytes. So 2 times 16, it's going to need 12 bytes in the memory. So from the beginning here to the end here, it's going to be 12 bytes. But arrays do not keep track of the end. They just know where they're starting. They don't know where the end is. The end can change. That's something that we have to keep track of. So it's going to create a space for 6 variables of size int, and they're going to be right after each other. And we are starting at 0. The reason that we are starting at 0 is the name of your array and the address of the beginning of array are exactly the same thing. That means if I starting from here, and let's say this is 1 million, the name of the array and the index 0, they have the same address. And we're going to talk a little more on how is this calculated. So if I want to go to element number 4, which has index 3, it's going to take this 3, it's going to multiply it by size of data type that we are using, the size of int, the size of double, the size of character, and so on and so forth. And then it knows where to go with that. So this is my ugly way of showing it, and your book has a different way of displaying this one. So your book is displaying the memory like this. So it's using a very, very small one. So in reality, this is not happening anymore. This is early computers. So the integer size over here is the size of my integer is 2 byte, which is 16 bits. That is the size of this integer of this machine. So when it creates an array in a memory, in the data section of the memory, it's going to go in the location 1023. So every time it works, and it's going to put 2 times 6, that's 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what I have for my array. The example was if I want A3, I'm going to take the 3 times 2, that's going to give me 6. So I start from here, 0, 1, 2, 3, 4, 5, 6. That's going to be the starting point of my A3. Now, why does it start with index 0? Because if I take the 0, I multiply it by 2, that's going to give me 0, and I'm going to add it to the beginning of the address, that's going to be 1023. That's why we have 0 here. So in A3, what we took for the A bracket 3, we got 3 times 2, that's going to give us 6. We're going to take the 6 and we're going to add it to 1023, which is our starting point of our array. So it's going to add it to that plus 6. That's going to give me 1029. Again, because this is a high level language, we don't have to worry about it. These things happen behind the scene. I don't have to worry about it, but that's what happens in the memory. Now, what happens is if we do outside of our array, remember, all it knows, where is it starting? So it knows where is it starting. It knows its data type. That's all it knows. It doesn't know anything else. It just keep tracking of where is it starting and what data type it has. So based on that, it can calculate where to go. Now, remember, 5 is the size. If I did a mistake of saying A5 equal some number. Okay, what is it going to do? It's going to take the 5, it's going to multiply it by 2, it's going to get 10, it's going to use 1023 at the beginning of the array, it's going to add 10 to it, that's going to give me 1033. Well, this is 6, I'm sorry. So let me use, so, okay. So the size is 6, it's not 5. So it's going to go to 1033, and it's going to put 67 in 1033, which is right here. Now, what about if I do, what about if I do 6? So I have bracket 6. I'm going to put 88 in there. Now, 6 times 2 is going to give me 12. And 1023 plus 12 is going to give me 23. So what is 1023 plus 12? 1035. So it's going to go to location 1035, which is outside of my array, and it's going to put it right there. C++ is not checking for that. It only knows where it's starting, and it knows what's the size of data type. I'm going to get back to this. So a very common mistake is I have a size of 6, and I go put something in size 6. So in this case, my size is 5. That means my index is from 0 to 4. And the very, very common mistake at the beginning is we would use a 5 equals something. So in this case, whatever. So there is no A5 in my array. But C++ does not check it, so it's going to go in the memory and it's going to write it in there. And that is most likely another variable from somewhere else. So all of a sudden, your counter is going to be changed. So your counter was going 1, 2, 3, 4, 5, all of a sudden becomes 67, or some other variable. It depends on what is it in that location. So that's what C++ does. It does not complain about it. It does not say anything. It just goes in there and just put it right there. So that's the second thing. So the first thing we got to get used to starting with 0. Second thing, we got to start getting used to that if I have a size 5, I cannot put anything in index 5. So if I declare a couple of things in my program, then if I put A5 equal 93, it's going to go in there and it's going to change a variable that exists over here. I don't want to get too detailed on that one for our class, but that's the way it's going to be. So remember what we talked about the memory location. So now I have a 6 and we're creating an I7. And what happens if the statement AI equal 238 is executed? Think about it for a minute. What's going to happen if I say AI equal 238? So it's going to take the 7, because I is 7. It's going to multiply it by the data type. The old computer that we're using has 2 bytes. So it's going to do 7 times 2. And then it's going to go to that location. And it's going to just write 238 in there. There is no warning taken. So this is A5 over here. This is A6 over here. This is A7 over here, and so on and so forth. So if you look at some history, early banking, they were creating some kind of programs to go outside of the array and do some stuff. The early viruses were built that way too. So because arrays don't check something on the end of it, they were able to add some stuff in there and just leave it there or do something about it. So that's what it is for arrays. So far we have to remember 2 things. 1, the index is started at 0. 2, the last index is 1 less than size. Okay, so I'm going to stop right here so you get a little chance to think about these questions, and you can pause it or write it down. The best way to do it is write it down, because sometimes you read it, you think you know the answer, but when you write it down, you might change your thinking. And if you have any questions, bring it to the class or post it on a DQ and we can talk about it.